Okay, so this is the review for the Unit 3 test on designing studies. So, number one, the school's newspaper has asked you to contact 100 of the approximately 1,100 students at your school to gather information about the student opinions regarding food at your school's cafeteria. With as much precision, describe the population of your study. So it depends on whether or not we randomly select or not. If we do not randomly select, then our population is just 100 people that we actually contacted. If we randomly select 100 people, then our population are students at our school. And so it didn't say we randomly select, so we would say our population is the 100 students who we got their opinion, because we can't make any generalities about the general population unless we randomly select it. If we randomly selected, then it would be the opinion of students at the school. All right, so this one is asking us to stratify our data. So here we would select 50 males and select 50 females. Whoops, sorry. I forgot the very important word. We're assuming that it's 50% male-female at the high school. It should be. Should be close. The advantage is that I can't spell, guarantee that we will get representation of both male and female, because gender is a potentially confounding variable. And so this is stratified sampling. And we stratify to handle in case there is a potential confounding variable. All right, two different organizations conduct polls in a city whose mayor has been accused of taking bribes. One poll asks an SRS, remember simple random sample, of city residents, do you think the mayor should resign because of accusations of his criminal activity? The other asks, do you think the mayor should resign? The first poll concluded the majority of city residents think that the mayor should resign. The second poll drew exactly the opposite conclusion. Explain why the results may be so different. Well, they led with this, is that you're assuming that the general population is aware of the accusations of criminal activity. Sorry, that's why they were different right there. And so, it's really funny, Jimmy Kimmel does this all the time with polls, is he'll ask a leading question and then get you to answer that. Or even ask you something that's nonsense and get people to respond. Is if you ask someone a question, they're going to ask, do you think the mayor should resign? And then you'll get a yes or a no. But if you ask it with the accusations of criminal activity, people who A, weren't aware of the criminal activity, or B, didn't understand what was going on, will answer the other way. So you have to be very careful about that. Your school will send a delegation of 35 seniors to a student life convention. 200 boys and 150 girls are eligible to be chosen. A sample of 20 girls and a separate sample of 15 boys are each randomly selected. So, is it an SRS? No, it is a stratified random sample. Because we're not choosing from the population, we couldn't get remember, an SRS, every single possible combination in the population has the same chance, or has a chance to be chosen, and there's no way we could get a sample of 35 girls or 35 boys. So beginning at line 108, and this, okay, so what we're going to do is we're going to select 3-digit blocks. Actually, we should, before we do that, assign all girls a number 0, 0, 1 to 200. Select 3-digit blocks. If number is between 0, 0, 1 and 200, select girl associated with that number. If number not, exclude, and keep going. So, ready? Starting at line 108. Exclude, 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 exclude. Oh, that's a 1. It's very important that we get that. Exclude. There. First number selected is 179. Second number selected is 090. Exclude. 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 336 is our next one. Exclude. And the last person is 009. So those are the first 3 people that would have been randomly selected using the 3-block method. We have to use 3 blocks because we need the potential to get anything between 0, 1, and 200. All right, let's do some multiple choice. The hemlock woolly adelgid is an insect that has accidentally been released in the U.S. forest from Asia. Since it has no natural enemies in the U.S., it is spreading rapidly. A forester studying the abundance of insects in southern Vermont wants to determine if it has spread that far north. He randomly selects 200 hemlock trees in a large Vermont forest and finds that 46 of them show damage from the insect. All right, so it would be appropriate to generalize the results of the experiments to well, he randomly selected them. So the 200 is not. It applies to this, the large Vermont forest. The large Vermont forest was not randomly selected, so that's as far as the inference can go. So the answer is E. We say the design of a study is biased if which one of the following, and that's certain outcomes are systematically favored. That's what bias means, is that we're favoring a certain outcome. For a certain experiment, you have 8 subjects, 4 of which are male and 4 of which are female. The names of the subjects are listed below. There are 2 treatment groups, A and B. If a randomized block design is with each subject's blocked by gender, which one of the following is not possible? So if you're blocking by gender, remember you're splitting the population into males and then females, and then randomly assigning within the blocks the two treatments. So Atwater, Chu, King, Liu is possible. Bacon, Chu, Liu, Moore is possible. Atwater, Diaz, Liu, King is possible. Atwater, Bacon, Chu. This one's not possible because it has 3 boys for treatment in Group A. And we're only going to get 2 in A, 2 male A's and 2 male B's because we blocked ahead of time. So only half the males can receive treatment A. A Texas school district wants to compare the effectiveness of a standard AP statistics curriculum and a new hands-on AP statistics curriculum. 2 experienced teachers, Mr. Pryor and Mr. Legacy, are each given 1 class with the standard curriculum and 1 with the new approach. Students are assigned at random to these 4 classes. At the end of the year, all students take the AP statistics class. The subjects in the experiment are, all right, remember subjects is who we're giving treatments to. So the treatments are the students in the 4 classes. This is the treatments. All right, the 2 AP statistics curricula are the treatments, but the treatments are being given to the subjects, and the subjects are the students assigned to the class. Materials engineer wishes to compare the durability of 2 different types of paving material. She has 40 different 1-mile stretches of interstate that she's been authorized to repave for the study. She decides to carry out a match pairs experiment. Which of the following is the best way for her to carry out randomization of this study? All right, so she's going to match pairs. So use a table of random digits to divide the 40 roadways into 20 pairs, and then for each pair, flip a coin to decide which pavement to use. That's not really a match pair, because the whole point of the match pairs is that everything's the same, so that if there's 40 different stretches of roadway, they're in very different places. So you're not matching anything. So that's out. Subjectively divide the roadway into 20 pairs, making the roadways with each pair as different as possible. Well, that's right away, because the whole point of a match pairs is that the pairs are as similar as possible. Once again, use a table of random digits to divide the 40 roadways into 2 groups of 20, and then use a table of random digits a second time. This is just doubling your randomness, but it's still not matching them. Let each of the 40 roadways act as its own pair, dividing the roadway into the first half mile and the second half miles. All right, so now we're getting somewhere. Flip a coin of the 40 roadways to decide which half mile gets the pavement. E is the same thing, but it's flip a coin to decide which pavement is put on the first half mile of all the roadways. See, that's no good. We want to randomly select within each pair. So the correct answer would be D. All right, does ginkgo improve memory? The law allows marketers of herbs, and other natural substances to make health claims that are not supported by evidence. Brands of ginkgo extract claim to improve memory and concentration. A randomization experiment found that no statistical significant evidence for such effects. The subjects were 230 healthy volunteers over 60 years old. They were randomly assigned to a ginkgo or a placebo pill. All the subjects took a battery of tests for learning before the treatment started, and again after 6 weeks. The study was double-blind. So what does this mean? That means that volunteers and evaluators, the people administering the tests for learning and memory, did not know who received ginkgo or placebo. Comment briefly on to what the extent the results of the study can be generalized to some larger population and to the extent which cause and effect has been established. Well, if so basically, because it was volunteers, you cannot generalize to the larger population because volunteers were not randomly selected. Now, because it was an experiment, cause and effect would have been proved if we had received statistically significant evidence, but there was no statistically significant evidence, so no conclusion can be made about cause and effect because of lack of evidence. Explain why it is advantageous to use 230 volunteers and say rather than 30. Well, as n increases, we get better replication. So we are more likely to get statistically significant results. Results. Sorry, smartboard got a little weird there. So basically, is when we increase the size of the study, we're much more likely to get good results. We eliminate the chance that things will happen by random chance. If we have a small sample size, we can just get weird results by random chance. And we'll see this in the upcoming units as we start to look at probability. The probability of one weird thing happening is actually pretty low. The probability of many, many weird things happening is very high. So that's it for the review for the test. Make sure you study, make sure you do the review pages at the end of the chapter, and good luck.